Hey everyone, welcome to Tutoring. I hope you're having a great day. Today we are doing chapter 6b, question 7, which is your differentiation chapter. This question is actually very intriguing. It's actually quite similar to what you study in methods, but they've put a special flavor into the question. Right, so let's look into the question and you'll see what I'm talking about. Question 7, part A and part B, there's two parts. Part A says, show that the graphs of x equals to y squared minus y, whatever this graph is, we're not supposed to sketch it, so don't worry, and y equals to half x plus 1, we know what this is, that's just a straight linear line, intersect where x equals 2, and find the coordinates of this point. So we need to show that these two graphs intersect at x equals 2, and then just find the coordinates of the intersection, so the y coordinate as well, okay? And then part B, we'll answer that soon. Let's do part A first. So show that the graph, intersect each other at this point. Well, if you want to do that, guys, just make the graph equal to each other, or in this case, we substitute one of them into the other. Okay, so which one do we substitute in? Well, we know that this is x in terms of y, and then it's got all this y stuff. We can just chuck this right over here, okay? So that's half y squared minus y plus 1, guys. And you end up with half y squared minus half y plus 1. Bring everything over, so that's half y squared. I'm going to bring the y over to the right hand side, and we get minus 3 on 2y plus 1 equals 0. The denominator, there's 2 here, the fraction is just making it very messy, so I'll times both sides by 2 to get rid of the 2 in the denominator. So that is y squared minus 3y plus 2, because we multiply by 2 as well. 2 times 0 is 0, and we have this. Well, we can factorize this, crisscross, y minus 2, y minus 1 equals to 0, guys, and you're left with y equals 2 or y equals 1. So 2 answers. What happens now? Well, we need to show that it intersects at x equals 2. So we need to find the x coordinate as well, okay? So if you want to find the x coordinate of y equals 2, you sub it in into whichever equation you want. I'm going to sub into the line because that's easier. So 2 equals to half x plus 1, that's the equation of the line. And let's solve for x. So that is 2 minus 1, that's 1, and then times it by 2. So therefore x equals 2. So that's pretty much what we need. If you want to find the other point, you can as well, but you don't really have to because you already showed that it intersect at x equals 2. But let's just do it here. Y equals 1 half x plus 1. So 1 minus 1 is 0, times it by 2 is still 0. X equals 2. So your intersection points are 2, 2 and 0, 1, okay? So that answers part A. It also answers find the coordinates of this point. So that's our coordinates, 2, 2. And we did show that intersect at x equals 2. Now let's move on to part B. This is what I want to go through, okay guys? So let's read. Part B, find corrected 2 decimal places. So this is already a calculated question. The angle between the line y equals to half x plus 1, so this line right here, and the tangent to the graph of x equals to y squared minus y at the point of intersection found in part A. So we don't know the curve of this, but we just need to find the tangent at the intersection, right? So we can definitely do that. So if you want to find the tangent, it is y equals mx plus c. We need to find m and we need to find c. Right, and if you want to find m, the gradient, well, in this case, we've learned this is a differentiation chapter, you derive. So let's derive. We need to find dy dx. So in this case, for this curve, you find the x dy first, because you can't find dy dx, right? It's x in terms of y. So the x dy, and we can always flip it over. That's the good thing about special. So we derive in terms of y, that is 2y minus 1, and then we flip it over, so that it becomes dy dx. It is now 1 over 2y minus 1. And of course, if you want to get the actual gradient, you sub in y equals 2. Well, the point of intersection is that y equals 2. So we sub in y equals 2, and you're left with 1 over 2 times 2 is 4. 4 minus 1 is 3. So that is the gradient, okay? So the gradient is 1 over 3. And you actually don't have to find plus c, but for illustration purposes, I'll show you what plus c is. So what we have is y equals 1 over 3x plus c. And of course, if you want to solve for c, you sub in the coordinates of the intersection, 2, 2. So it's almost like methods, guys. This is essentially doing methods all over again, but with a special technique in there. So this differentiation. Right, so 2 equals to 2 over 3 plus c, so therefore c equals to 2 minus 2 over 3, which will get 4 over 3. So your tangent is y equals to 1 on 3x plus 4 over 3. Okay, we haven't finished the question. We need to find the angle between the tangent and this line. Like, how does that work? Well, let's just draw it first, right? So I'm going to draw on the axes the line and the tangent. Okay, we don't need to worry about the curve, we can't sketch that. Y equals to 1 on 3x plus 4 on 3. So the y-intercept is 4 on 3, and the tangent is 1 on 3. So I'm just going to give you a rough sketch on what this looks like. Maybe something like this, okay? Something like this. So straight line, intersect at 4 on 3, gradient is 1 on 3, okay? Okay, now I'm going to sketch you the line, y equals half x plus 1. So the y-intercept here is 1, and then it should intersect at x equals 2. So wherever x equals 2 is, the gradient, so this line intersects the tangent. I don't know the shape. Oh, this is a terrible graph. I'm gonna try my best, but whoop, half. So nope, that does not work at all. Okay, right there. Okay, so that is y equals to half x plus 1. Yes, I know it's a bit skewed, but if you draw to scale on your book, it should be fine. And when you find this angle right there, okay, the angle within these, between these two lines. Okay, how would you find that angle? Well, if you want to find the angle, here's what I'll draw. I'll draw a horizontal line right here to help you visualize, okay? So horizontal line to help you visualize the two angles that we need to find the angle in between. Okay. If you want to find this, you need to find the bigger angle, so the angle between this horizontal line right here and the red line, so y equals half x plus 1. So the big angle, I'll put it in red as well. So this angle right here, we'll call that alpha. And then we need to find this black angle, which is the angle between the horizontal line and the tangent line. So this one right here, and I'll call that beta, okay? You name it whatever you like, but alpha and beta. If you go alpha minus beta, then that would give you the angle in between. So how would you now find alpha and beta? Well, alpha, using what we learned in special, this angle right here, with your geometry angle rules, you know, this, if that's alpha, this is also alpha. And if that's beta, then that's also beta, okay? So this angle right here, that's beta. Right, so that's using your geometry for what we did in year 11. Right, so that's alpha and that's beta. So after that, how would you find the actual angle? Well, so beta is the angle of the tangent. If you want to find beta, we have a formula, and that is tan inverse of the gradient, right? Tan inverse of the gradient. And if you want to find alpha, it's the same thing. That is tan inverse of the gradient of the line, okay? So in this case, that's half. And then if you want to find the angle between, which one's bigger? Alpha is bigger than beta. So the angle in between, I'll call it theta. Theta is equals to tan inverse of half. So the alpha, the bigger angle, minus tan inverse of 1 and 3. So hopefully you can see the picture right here, because this formula, the tan inverse formula, only works if it's between the x-axis, and that's how we're doing it right now, okay? So if you do this on your calculator, obviously you can't do this by hand, but if you do it on the calculator, guys, your final answer should be 8.13 degrees. So just chuck inside your calculator, and that's what you should end up with. Okay, hopefully you found this video useful, and if you did find it useful, leave a like. But aside from that, guys, I'll see you in the next video. Thanks for watching.